Hello, my name is Tony Rogers and welcome to a special video where I'm going to review certain types of signals intelligence, noise interference, machine learning, spoofing technologies, and drone interference, robotics, and even spatial computers, and how some signals and how we can actually inject certain types of electromagnetic noise or radiation to interfere with these types of technology, okay? So a little background on me. For many years, I was Air Force Special Operations Command. I worked on the AC-130 gunships, the B-52s, the A-10s. I've worked on all kinds of radio frequency receive transmit systems, infrared barrage jamming systems, the AOQ-172, AAR-44A infrared barrage jamming system. I've also worked on certain types of technologies in Joint Task Force Troy out of Naval Explosive Ordnance, NAVEO detective out of Indian Head, Maryland. I've worked on the ICE, the Green, the Blue, the Duke, the LX, the Spruce, the Chameleon, and all kinds of different systems back when I used to have a clearance 15 years ago. And now, ironically, many of these kinds of electromagnetic interference, like signals intelligence kind of techniques, are being transferred over into new types of emerging technologies like spatial computing and more specifically robotics. And how we can do this, and we can look at drones per se, where drones are communicating over certain types of frequencies, over 900 megahertz or 2.4 gigahertz or even 5 gigahertz, depending on how it is designed. And you can create certain types of jamming systems. I'll throw one of those up here. And there's all kinds of different funded projects around the world that are looking at mitigating, communicating to these devices, with certain types of radio frequency barrage jamming systems, or even passive reactive systems that are listening and then jamming certain frequencies at a certain power level. And I think this is going to disrupt many different types of technological markets, vertical markets across the world. And you're already seeing this with autonomous navigation, with machine learning algorithms, and those systems are being trained with neural nets with millions and millions and millions of different images. However, you find on the image data sets that they're using, you only need to make a very small, subtle change in order to cause a negative consequence or a negative impact from the vision system, right? So let's take a Tesla, navigation system per se. Now Tesla has 60 gigahertz radar coupled with 8 pairs of stereoscopic eyes, right? And they can see very well during the day, and at night they're relying a little bit more on radar and the neural net, the spatial maps that they're sharing between 1 million vehicles, okay? But what you see now is, various different types of hackers around the world are using different technologies to mark up signs, to interfere with its ability to actually detect, yes, that's a sign, that's a stoplight, that's a person, and it only takes a small subtle change, like even wearing different colors on a person's clothing to discern or cover certain body parts where they can't detect that person. This is only the beginning of an explosion of different technologies and hackers attacking these pieces of technology, more specifically in spatial computing as well. Drones is massive. They're going to experience a catastrophic inflow of mitigating techniques and companies that are going to be targeting these systems. There's a lot of different business owners that don't want drones flying around all over the place, and whether or not you have the right to shoot that out of the air is up to the FCC and the government and the policymakers, but this stuff is already here. You can design it and implement it as an engineer. It's fairly simple to do. And I think about the spoofing of machine learning algorithms and perception engines and neural nets and autonomous navigation. That's going to be terribly disruptive and catastrophic. If you think about the coming disruption, the innovative disruptive techniques and technologies coming from 10 million autonomous navigation in trucking systems and logistics across the entire United States, now you'll have different drone technologies that could be going on, interfering with some of those technologies very simply and very easily. And we can take one of these systems here, and I show you guys quite a bit about crosstalk or interference or noise. And it's easy to do. You look at a vertical cavity surface emitting laser on a spatial computer. These systems are using class 1 lasers between 850 nanometers near infrared up to 940 nanometers. And again, you can simulate this. So if you had systems, in an area where there's a lot of spatial computers, a lot of virtual reality headsets that are using, let's say, LiDAR, light imaging detection and ranging systems, now you could have, hackers that could come in and disrupt and a portion of a city, an entire West Coast, or just small areas where they're blanketing it with certain types of electromagnetic noise. They're barrage jamming all of these systems, and I really worry about whether or not the designers of the big box manufacturers are thinking about this and implementing ways to shield and or prevent these other erroneous signals, which could be accidental, and that could also happen. But I'm more worried about the purposeful side of hacking communication systems, hacking signals intelligence systems, because it's exceedingly simple to do. And I've showcased that to you just in a few easy simulation and visualizations where I'm using either a structured light sensor or a coded light sensor or time of flight sensor or vertical cavity surface emitting laser, or even just straight up photogrammetry. Again, those systems can be negatively impacted by light and illumination, right? So moving forward, you'll need to have a hybrid based system where you're not only using LiDAR systems or vertical cavity surface emitting lasers, V cells, but also maybe some machine learning algorithms that are fighting actively against being attacked in this way and spoofed, because this is only just the beginning. Wait until we have 30 to 50 million vehicles all communicating on the highways and sharing their position, sharing accident data, sharing information over a neural net, maybe sharing even a 4D labeled data set in real time, which is what the Tesla systems are doing. I like to envision it as like a space-time bubble, in real time, and they're sharing all of those together. Let's say you had a radar system where you're going out there and you're pumping 10 to 15 watts out. Now you're interfering with these systems' ability to actually infer and understand their environment via their advanced perception engines. And this is not as sophisticated as you might believe or think it is, because there's a lot of engineers out there that fully understand these types of signals, down to electrical engineering perspective. But moving forward, hackers are going to see this as a major component to come in and siphon resources from organizations. You can hack their networks in this fashion if you can get into the sensor stream. And that's what I really think about with virtual reality headsets and spatial computing headsets, is you have everybody wearing these headsets maybe in large areas, 100 people, 500 people, all playing games in real time. And if somebody came in with some kind of a signal that was along the same wavelength as maybe on a hybrid system that they're using, again 850 nanometers, you could disrupt the entire game in a heartbeat, right? Or you could get into the system and start manipulating information very, very easily and simply. And communicating moving forward, everything is going to move forward into spatial computing. We're not going to be using cell phones anymore. I think, as I often say, that the future's already here, it's just not evenly distributed. This is really 100% true, like on orders of magnitude. You just don't understand it yet, because everybody's really continuing to use a technology that we've grown accustomed to using for the last 13 years. It's just terribly difficult to get rid of. We're all addicted to using cell phone technology, but as soon as we shift over to this technology, and this is coming, it's very, very close. We've been saying this for 7 years, and everyone's like, oh, it's going to be here next year. It might not be here next year. Apple keeps pushing their thing out. Apple will come out with their virtual reality / mixed reality device next year, and then their AR device in 2024, 2025. But again, they're already talking about implementing LiDAR sensors on that camera, and every other device that I've looked at is also integrating LiDAR or radar or V cell or time of flight or coded light or structured light, and all of these signals can be essentially intercepted. I think of international mobile subscriber identifiers on your phone. That's the same kind of premise. We used to talk about using stingrays to intercept communications overseas, back when I was in the military, and that's the same premise. Your phone, every time you make a phone call, is going out trying to find the nearest cell phone tower, and it has an IMSI. We call it an IMSI catcher. It's the same premise, where all of these signals, all of these identifiers, the GPS geolocation, geographic fencing, and then also your locality information. So as you're sending information out via these photons and it's coming back, and then you go out into the world, into social environments where you could potentially have perpetrators there waiting and injecting signals into your spatial computer, into your virtual reality headset. They could potentially even swap telepresence. They can make it look like you're in a different place than you really are. And I'll give you an example. Like if you went up to a system that is using QR codes only, and somebody was able to spoof the QR code your sensor system thought it saw, it would pull up a different spatial map, right, than what is actually currently present within the perception engine. So now you have a completely different environmental 3D system than where you are, and you're spoofing remote holoportation and telepresence. That sounds like Star Trek, but it's not. That stuff is here. It's already being probably used, I would say, on the hacker side of certain kind of drone technology, more specifically, absolutely, and electronic warfare in combat and stuff like that. But I foresee it in virtual reality devices as well. I mean, I know in the Oculus Quest right now, they only have 4, monochromatic cameras on the front there, and those monochrome cameras right now they're not color, they're not fast, but they're going to update that. So in Oculus Quest 3, Oculus Quest 4, you'll have infrared eye tracking, and I worry about that too. Essentially, geometric tracking of your face via other kinds of spoofing technologies and techniques. Again, you're going to have hand tracking, skeletal tracking. All of these different systems are going to be shared biometric information about you over the network. And I often wonder and worry, like, where are the safeguards being implemented in the electrical engineering and the IT infrastructure, the cybersecurity side on these kinds of systems when we have exposed sensor data, we have exposed perception engines, we have exposed neural nets, from, I don't know, 150 million devices, right? So right now when we use our devices, they're not constantly mapping their environment. But in the very near future, this is going to be a common methodology and implementation across all electronic devices, spatial computing, mobile electronics. It's going to be common. If you're not doing it, you're not going to be competitive. So what kind of safeguards are being implemented to mitigate this, to prevent your own biometric data, your own security from being stolen? I worry about your house. Like if you're using a spatial computer in your house and it's mapped your entire environment in 3D, where that information is being stored, you could easily access that information with certain types of systems. And now you would have access to everything that's in your house. You would also have access to all of your biometric data, your eye tracking data, your facial recognition, which is really amazing. The geometric tracking there is unbelievably advanced. I showed you some simple applications that I made here in the Batcave. Remember, if I can do it, then imagine what you can do with an unlimited budget. You can do some unbelievable things in technology nowadays, and I do all this stuff by myself just to showcase to you all out there like what's possible on a shoestring budget, and then what's really possible if you open up your eyes, what's really happening underneath the iceberg. That's always a great analogy, right? You see the iceberg just a little bit sticking out from the top of the ocean. What's happening underneath all that? A ton of advancements, more than you could possibly imagine. I try to keep up every single day, and it's very difficult and challenging for me to do it. And I would never posit that somebody else could keep up with such a busy life and so many different distractions, okay? So I hope this kind of very brief discussion helps you understand all the different signals that are in the air. It's not only, we think of radar at 60 gigahertz and the Project Soli system on the Google Pixel. I'll be coming up with a video of that very soon for tracking systems. That's amazing. But they actually banned that phone in overseas countries, and I'll tell you why they banned it. Because that 60 gigahertz radar signal can interfere with other kinds of systems. Some of them are military systems, some of them are top secret systems, and they don't want everybody out there with a 60 gigahertz transmitter walking through the airport or walking through different transportation systems and train stations because it can negatively impact these systems. We've seen that before. I always give the analogy like when I used to train people in Navio Detective when I was in Iraq and Afghanistan on implementing certain systems like the red, the green, the blue, the Duke, the LX, all in the same space so you can't shut down communications, is like we never would install a system and ask it to effectively communicate near a train, right? The train would be the receiver, and all of a sudden the train comes really close and it gets really loud and the noise floor raises and nothing can be received. And then I'll finalize the video with this. These spoofing techniques, finding anomalies in the way the information is being processed via the perception engine from these machine learning models, coupled with all the different types of sensors that we previously discussed, is going to be a huge, massive issue moving forward. And it's actually right around the corner. You have researchers at the University of Michigan posting papers like this from 2019, 2020, actually simulating these spoofs, looking at red lights, looking at how you can actually force the autonomous navigation system to initiate an emergency braking system, looking at forcing it to think that there are 20 cars in front of it when there are 0 cars. We used to do this in the military. Actually, this is the basis of electronic warfare, is sprinkling all kinds of aluminum in the air right before you're about to fly through, so the radar systems think there's 300 planes in the air, but there's only one AC-130. That's the same kind of premise. All of that stuff is being transferred over into this intelligence, these gathering systems, these information systems that are looking at all these different sensors, these million, in the future, billions of data points and billions of sensors, and the ability to actually pluck off arrays of different sensors and make it think that it's seeing something that's not there. So the system that you're currently riding in, a car, a train, a truck, a snowmobile, whatever has the full autonomous navigation suite, but you're also controlling a drone, controlling suites of drones, putting water out over different fires for emergency responders, looking for people. I mean, this is so far-reaching for spoofing intelligence systems, spoofing communication systems, something that I'm very adept at. I was trained by the United States military. I know all of the ways that you could potentially do it with an unlimited budget. And now all of that stuff 15, 16 years later is just trickling down into consumer markets, consumer products, and not just industrial things in vertical markets like DARPA-funded projects that you never really see the light of day. These things are here, and people are becoming more aware of how they can actually go in, attack a system as an adversary, and cause a negative consequence for that side, but also a positive outcome for the other side, which is just as important to understand, right? You have competing systems always trying to identify and understand who's trying to spoof them, who's shooting structured light at you, who's shooting an array of LiDAR systems at you to make you think that sign is not a sign, or that person's not a person, or that light is not the right color. I mean, these things they're far-reaching, they're expansive. I try to think about them every single day, but it worries me, and that's why I create these videos, to try to showcase and share my information and knowledge with you, but also see the things that you're interested in. What are the aspects of this that bother you the most when it comes to security of your own devices, your own mobile electronics, but also the assurances that you're being provided that these pieces of technological wonders, these amazing, disruptive, innovative technologies and products are being protected against someone from coming in and actually manipulating the way that it is supposed to operate. Thank you so much for paying attention to this original video here, looking at signals intelligence and crosstalk and interference and noise, and how in the future all of our mobile electronics, spatial computers, virtual reality devices, autonomous navigation, and robotic systems will be open to these kind of adversarial attacks. And we need to start proactively thinking about how we can start mitigating them now, because if we wait too long, it'll just be like a thermal runaway event, and it'll just run off and there'll be nothing stopping it. It'll be a constant, okay, you're doing this, we're gonna do this, and you're gonna do that, and we're gonna just keep jumping up, and it'll never end, okay? Thank you so much, I appreciate it, you have a wonderful day.